Hello there, this is Professor Eckhouse, and I am going to talk today about section 1.4, multiplying whole numbers. Again, the things in green I am not going to take the time to talk about. There's plenty of videos and example problems in the book on using symbolism words to represent multiplication. So what is the most efficient way to determine the number of circles in this picture here? What is the most efficient way? I would say that there is 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2, 3. So 8 times 3. This is called an area model, so there are 24 circles. In general, it's much faster than counting, especially when you have large amounts of things. So how would we model these multiplication problems here? So 2 times 3. You can do it a couple different ways, but I'm going to go 1, 2, 3, and we have 2 sets of 3. So that's a way to model that. The next one, 3 times 5. So I've got 3 sets of 5, or I could say I have 5 sets of 3. It doesn't really matter. I'm going to do 3 sets of 5. 1, 2, 3, 4, 5. That's 1 set. 1, 2, 3, 4, 5. That's 2 sets. 1, 2, 3, 4, 5. That's 3 sets. So now we have 3 and 5. 3 by 5 is 15. So again, using an area model to multiply. All right, so multiplication table. Multiplication table is in your handouts in OneNote. There may be one in Lumen too. If anybody wants it in Lumen, I can put it there too, but it's very easy to get to in OneNote. You can write on it in OneNote, or you can print the PDF. So you can use a multiplication table as much as you want to practice, and I highly recommend having it sitting right in front of you while you're working. And you can do things like, highlight the perfect squares so you can see right down the middle. The perfect squares are right there. So 2 times 2, 3 times 3, 4 times 4, and so on. Okay, so use lots of tools to make sure you know your multiplication facts. People who don't like fractions generally, the problem is that they don't know their multiplication facts. So if you know your multiplication facts really well, fractions are much, much easier. And we'll talk about that when we get to fractions. But start practicing them now. All right, so properties of multiplication. These you need to know. The multiplication property of 0. Anything times 0 is 0. It doesn't matter what order you do it in. The identity property of multiplication is anything times 1 is itself. So 1 times A is A times 1 is A. It doesn't really matter what order you do it in. The commutative property is just like addition. You can do it in any order. So 1 times 2 or 2 times 1, they both equal 2. All right, the multiplication algorithm, by that we mean when we take numbers like 5,263 and we multiply it times 20, I'm just making this up, times 24, and you do an algorithm. I'm not going over that. That is in the book. There's lots of videos online. You can go to Khan Academy and things like that. All right, so I do want to talk about multiplying by powers of 10 because this leads to decimals and things that we're going to be doing. We use a base 10 number system. So when we multiply by 10, all we have to do is move the decimal point to the right 1 place. If we multiply by 100, 2 places, 1,000, 3 places. So the number of zeros is the number of places it goes to the right. When you're multiplying, also, you can just tack on a 0, basically. So that makes that a lot easier. If there's decimals, though, in the number, if it's not a whole number, you have to think move decimal place. Okay, so 26, the decimal place is here. We would move it to the right 1 place, and it would become 260. Okay, 260. As you can see, we just tacked on a 0. So if you just tack on the 0, you end up with 2,600, and here 26,000. So 26 times 1,000 is 26,000. 26 times 100 is 2,600. A couple different ways to think about that. If you move the decimal place, you would have it's here. 100 is 2 decimal places, so 1, 2, and it looks like that. Okay, so a couple different ways to think about those problems. All right, if you have 3 or more factors, of course, let's go back up and think about this. The commutative property says you can do things in any order. Changing the order doesn't matter. So as long as there's nothing else there besides multiplication, you can do this in any order. Now, this becomes really important when we get to fractions, for reducing fractions and things like that, just to know that you can change the order of this in any way you need to. Here they took 8 times 3, and they got 24, and then they just carried down the 2, and then they multiplied the 24 times the 2 to get 48. Is there another way to do this? Well, yeah, there's another way to do this. You could say, I'm going to multiply these two and get 6 and carry down the 8. And then I'm going to multiply these two and get 48. Either way, you get 48. So it doesn't matter what order you do it in. All right, so again, we're going to translate word phrases to math notation. Words you're going to see are times, product, twice, double, triple. We don't very often say quadruple, but you might see it once in a while. After that, we just say times 5 or times 6. The word of, 1/2 of, means that we multiply it. This is really important. A lot of people don't realize this. It means, see, the of means times. 1/2 times 10. We're going to get to fractions later, but of means times. So the product of 12 and 3. So 12 and 3 are what we call, these are called factors. Okay, these are factors. They're being multiplied together. So we get product of, and we get 36. Okay, another way to think about these is when we see a word like twice. Twice means, this means 2 times. Okay, so I try not to use an X, so we're going to make that a dot, because an X looks like an X, and we're going to get into pre-algebra, and so when we use times, we use a dot, or we set them side by side with parentheses, but I use dots usually. Twice 112, so that means twice means 2 times something equals, right? So we're going to say 2 times 112, and that's going to be 224. Okay, so notice since all these numbers are less than 5, you just double each one, double each digit, I should say digit, not number. So each digit in 112 is less than 5, so I say times 2, I can just say 224. All right, multiplying whole numbers in applications. Example 4. Draw pictures whenever possible. So whenever you can, you want to draw a picture. It really does help. So I'm going to say Humberto bought 4 sheets of stamps. All right, so I've got 1, 2, I don't know what shape they are. I don't really care. I'm just doing this for myself. So 4 sheets. So each sheet has 20 stamps. In a textbook or something, you might see that they've done a really nice job of separating that into 20 in each one, but just write 20. So how many stamps did Humberto buy? So 20 times 4. Okay, so we would just say 20 times 4 is 80. So 80 stamps. Okay, the next one, when Rena cooks rice, she uses twice as much water as rice. So there's just different ways to draw this, but I'm going to say, okay, here's my rice, and I've got this little box, and then my water is going to be twice as big, just so I can kind of keep track of what's going on, rice and water. You can draw a little cup and half a cup and a whole cup, whatever you want to do. So this means that the water is always going to be twice the rice. Okay, so I'm converting it into math language. So water is equals twice is 2 times the rice. And we're going to get lots of practice with translating. Is always the equal sign. Okay, so water is twice the rice. And let's see, 4 cups of rice. So we're going to have 2 times 4 is 8 cups of water. All right, so these are the kind of things that trip people up with word problems, and I'm going to help you with that as much as possible throughout this class. Van is planning to build a patio. He will have 8 rows of tiles with 14 tiles in each row. How many tiles does he need for the patio? All right, so and I just realized I forgot to wear my headphones, so I am sorry about all the clicking and clacking of my my Apple Pencil. All right, so let's see. We've got 8 rows by 14 tiles. So if you need a picture, that's basically what's going on. 8 rows, or you could put the 8. If you think of rows as going this direction, you can say 8 rows 14 tiles in each one. So you're going to have 8 times 14, and that is 112 tiles. Okay, so area, we've been doing area. I've been using an area model already, so hopefully this feels fairly familiar, but now we're going to throw in units. So I just wanted you to think about if I have a box, right, that is a centimeter by a centimeter. So we've got a centimeter here, and we've got a centimeter here. Then we take 1 times 1, and this box is now 1 centimeter square. This is not to scale. 1 centimeter square, or 1 square centimeter. Okay, so 1 centimeter square, or we can say 1 square centimeter. All right, so this goes for all units. So down here, we've got 2 feet. So that means this right here is 1 foot, and this here is 1 foot. And this is 1 foot, and so is this, and so is this. So each of these boxes is 1 square foot. 1 square foot, 1 square foot, and so on. So we have, you can count them, 6 square feet. So that's how they get the answer, how we all get the answer. All right, 6 square feet. We take 2 times 3, and that gives us 6. Feet times feet is feet squared, is another way to think about it. All right, this is the last example. Jen's kitchen ceiling is a rectangle that measures 9 feet long by 12 feet wide. Right, so we've got 9 feet here and 12 feet here. I'm not going to draw all the little squares, but there would be 9 in one direction and 12 in the other direction. And so you're figuring out how many square feet, how many of those little square feet, you know, are in there. So you would just take 12 feet times 9 feet. And of course you can say 9 feet times 12 feet. It doesn't matter which way you do it. And you will get 108 square feet. So the feet squared to become feet squared. Okay, so another thing to think about here and keep in mind is this is just a rectangle, length times width. Okay, so this is, we just are using the formula really of length times width for the area of a rectangle. Okay, that is my last example. Thank you for watching.